Hello guys, welcome to example 2 on undetermined coefficients. So we want to use the method of undetermined coefficients, of course, which I'll advise for this particular case because the right hand side is actually an elementary form that we know. Okay, so undetermined coefficients will be more efficient in this method, although you can still use variation of parameters, but undetermined coefficients will be pretty much cooler to use. So you want to solve this, okay, given using undetermined coefficients y prime prime plus 6y prime plus 10y is equal to 2 sine 2x. So immediately, first step is to obtain your yp. Remember, y is equal to yc plus yp. Okay, so equation 0, let me establish this. So I'll obtain the form of my yp first of all. Now the form of my yp, since the right hand side it's a trigonometric form, I'll just assume, okay, an undetermined coefficient representation of this particular right hand side, and that is going to be a cos 2x. You can see I'm using the same frequencies, then plus b sine 2x. So this is the first form that I'm assuming that my particular integral is going to take. Okay, so this is the first form that my particular integral is going to take. This is the first thing you should do. Please and please don't forget, express yp first of all. And remember, I said in the last video that this expression of yp can still change later in the future. It depends on what you get in your yc. So let's obtain yc. So to obtain yc, you need to solve the characteristic equation from this particular case. So solving the characteristic equation, let me just jump straight to the characteristic equation. I'll have r squared plus what, 6 r plus 10 equal to 0. Okay, so remember, to obtain yc, you just need to equate this particular one to 0. That's y prime prime plus 6y prime plus 10 y equal to 0. So this will now be as if it was homogeneous, and you will now solve, okay, and solve using the method of auxiliary equations. Then the roots will now guide you into the solutions for yc. So solving, you get r is equal to minus 6 plus or minus the square root of 10 minus 4 into, sorry, the square root of 6 minus 4 into 10 over 2. And this gives me, if you solve it, it will give you negative 3 plus or minus j. Okay, if you solve it, to give you negative 3 plus or minus j. So after getting the roots, your yc, okay, according to the form of expressing complex roots, will have exponential negative 3x into c1 cos x plus c2 sine x. So sine 1x, and that one is coming from the invisible one that is standing in front of j over here. So this is the form of your what, yc, your complementary function. Now the next step is you need to compare this complementary function with your particular solution and ask yourself, is there any term that repeats itself? Okay, I can see a cos x and cos 2x, so there's no repetition. Sine 2x is not the same with sine x, no repetition. Okay, there's an exponential in my yc, there's no exponential in my yp. Therefore, since there's no repetition, this yp is valid. This yp in equation 1 is valid, and we can use it to determine, okay, the undetermined coefficients a and b. So yp must satisfy the differential equation y prime prime plus 6y prime plus 10y is equal to 2 sine 2x. So in other words, we are trying to say yp prime prime plus 6yp prime and plus 10yp should satisfy 2 sine 2x. So there becomes a need for us to obtain each of these yp prime and yp prime prime. So my yp is already given to me as a cos 2x plus b sine 2x. So let's obtain yp prime. So yp prime is going to be minus 2a when you differentiate sine 2x plus 2b cos 2x So yp prime prime is going to be, when you differentiate, you get negative 4a cos 2x, then negative 4b sine 2x. Okay, so you have obtained yp prime and yp prime prime. You now slot it into this equation so that you can test what happens to the coefficients. So starting with yp prime prime, I have negative 4a cos 2x, negative 4b sine 2x. So this is for yp prime prime, and plus 6 yp prime. So for yp prime, I have negative 2a sine 2x plus 2b cos 2x. Is that okay? Then plus 10 what? Okay, that's a cos 2x for yp, and plus b sine 2x, and this is equal to 2 sine 2x. Okay, 2 sine 2x. So sorry, alright, so we are going to collect the like terms. So let me start with terms in cos 2x. I'm going to collect all the terms in cos 2x first of all. Follow me carefully so that you will not have to waste much time expanding this bracket. So for the first bracket, I have a minus 4a as the coefficient. Then going to the second bracket, remember you have 6 times 2b. This is going to be a plus 12b. Okay, and when you go to the last bracket, you now have 10 times a is 10a. So all these ones are related to cos 2x. So I can still put a plus, then open a bracket. Okay, because plus is kind of like a neutral sign, so it will not really affect anything here. So let's go to terms in sine 2x now. So for sine 2x, I have this, I have this, and I have this. So for this, the coefficient is negative 4b. Then for this, the coefficient is negative 6 times 2a is negative 12a. Then for this last one, the coefficient is 10 times b is plus 10b. All of them are related to sine sine what? 2x, and this is equal to 2 sine 2x. Is that okay? So we are going to begin our comparison. So if you resolve this particular one, you can discover that cos 2x appears on the left hand side, but there is no cos 2x on the right hand side, or I can just say 0 cos 2x. Okay, so if you compare coefficients, the coefficient of cos 2x on the left hand side, it will evaluate to this, and this gives me 12b plus 6a. Okay, that's the coefficient of cos 2x on the left hand side. So cos 2x on the left hand side is 12b plus 6a, and on the right hand side the coefficient is 0. Okay, then for sine 2x, the coefficient of sine 2x on the left hand side, so let's resolve it. So if we resolve it, we'll have 6b on this side minus 12a. Okay, when we resolve this, you get 6b minus 12a, because minus 4b plus 10b is a 6b, and minus 12a is equal to, and the coefficient is what? 2. The coefficient of sine 2x on the right hand side is 2. So if we solve this system of equations, we are going to get for the first case, from equation, let me say 3 and equation 4. From equation 3, you're going to get 12b is equal to minus 6a, or in other words, a is equal to minus 2b. Is that okay? A is equal to minus 2b. So when you slot this a equal to minus 2b into this second equation, you're going to get 6b and minus 12 into minus 2b is equal to 2. So you get 6b plus 24b is equal to 2. In other words, 30b is equal to 2. Therefore, b is equal to 1 over 15. Is that okay? So b is equal to 1 over 15. So if b is equal to 1 over 15, a is equal to minus 2b. So a is equal to negative 2 1 over 15, and a is equal to minus 2 over 15. So a is minus 2 over 15 and b is 1 over 15. So for these two values, we have now gotten a and b. Therefore our yp is now going to be, according to the equation, our yp is a cos 2x plus b sin 2x. Is that okay? So a cos 2x, a is 1 over 15 cos 2x. Okay, then sorry about that, a is negative 2 over 15, so we have negative 2 over 15 cos 2x, and plus b is 1 over 15 over 15 sine 2x. Is that okay? So our complementary function yc is given to us as this value over here. So you have exponential negative 3x into c1 cos x plus c2 sine x. So if you solve for y is equal to yc plus yp, you now get y is equal to yc being exponential negative 3x into c1 cos x plus c2 sine x, and plus our yp is, let me see, starts with this one since it's positive, 1 over 15 sine 2x and minus 2 over 15 cos 2x. So this is the solution, or this is the general solution of the given differential equation. So I hope you see that the method is straightforward. Please like, share and subscribe. Hit the notification button to stay updated, and of course drop your comments, and if there's anything that you don't understand, I will gladly attend to it when I see it in the comment section. So for now, anticipate another video on undetermined coefficients, and stay safe till then.